Yes.
Okay, perfect. Yeah, so today we will be talking about embedded programming. And as Daniela explained a few weeks ago, embedded programming is about having a microcontroller as the brains of whatever system you want to implement. And the main difference between this and a computer is here you have the microcontroller, and the microcontroller has everything embedded inside of it. So you have already the RAM, the memory, the processor, or the processing power, all crammed into one chip. Yeah, opposed to a computer where you have the processor standalone, the memory, sticks, and the graphics card, and so on. And we will mainly focus on Arduino now as the first, let's say, entry-level embedded programming platform. And later on, Daniela's going to tell you a little bit about C programming, which is, let's say, a step deeper into the topic. And feel free to also explore even more deeper topics if you want to. This assignment is about programming at least using 2 different languages. And so far, for the past years, it has been acknowledged, or yeah, it's okay to program with Arduino, and let's see that already fulfills the assignment. But if you want to do assembly or something more sophisticated, feel free. Jeff, you need to mute.
¿Qué? O sea, estoy viendo que la llamada había sido hace 4 minutos, pero acaban de lanzar un nuevo.
Yeah, perfect.
Yeah.
We
can mute each other, it seems.
Yeah, that's good. Very good. Okay, so first of all, Arduino is a programming language, an IDE, so a software, a board, and a community. So the Arduino is not just the board or the programming language, it's all this package, let's say. And I personally think that's the biggest strength point of Arduino is the community behind it, because you can almost find sketches, so codes, libraries, and so on for almost everything you need to do. So first, I think it's a good idea to go through the interface. Yeah, the interface is rather simple, I would say. Here you have the area where you can make your sketch, basically write your program, and here you can verify. Verify means you compile the sketch. You make sure that you don't have any syntax errors, or you don't have any compilation errors. This is the upload button. You use this one to flash or to upload your sketch to the board, to the Arduino board. Here you can create a new sketch. Here you can open an old sketch, and here you can save the sketch. So this part is very straightforward. Here those navigation, drop-down menus or whatever, they are really also very typical as other programs.
Can we interrupt with a question?
Yeah, definitely.
So when you save the files on this in that Arduino interface, you save them, you upload them to the machine. Presumably you also save them onto the disk somewhere?
On the computer.
You upload whatever you've written there. We tend to take whatever we've written there, upload it to the embedded, to the Arduino.
Yeah.
And then when we want to work on it, we tend to download it off the Arduino, work on it, and then put it right back on the Arduino. So I don't think I have ever consciously saved the text or the program to disk somewhere.
Yeah, that's really important. So, yeah, I was gonna get to this later, but let's discuss it now. Yeah. So basically, once you hit upload, the code goes through a process of translation, compilation, and then even coding. Let's say you transform it into a way that the Arduino or the microcontroller would understand. And the thing is, once it's uploaded on the microcontroller, you cannot retrieve it at all. Presumably, there should be ways to do so, but I've never seen anyone do it before. it's almost impossible to get the code of the Arduino because it's compiled code. It's basically zeros and ones. So you always have to save your sketch somewhere as an Arduino project. But it's a text. It's a piece of text. You can put it in any text editor and save it. Even it doesn't have to be the extension, but you have to keep, of course, the text inside. If you have dependencies or if you have different sketches communicating or libraries or whatsoever, then it's a better idea to save it as an Arduino project, which I think the extension is INO or so.
Yeah, was one little comment about this. I think when you save the sketch, it goes automatically in a folder inside Documents in Windows. And there you have all your sketches. So if you want to look the sketches, you can look the sketches inside the Documents and /Arduino folder. And also, every sketch will have its own folder. It needs to be like alone inside a specific folder with all the parts that are imported together in the code. Sorry,
Yeah.
Ahmed.
No worries.
And presumably we can put that folder anywhere we want?
Yeah.
So it doesn't have to be necessarily in the documents directory.
No. It can be anywhere.
Okay.
Yeah.
Just a quick comment. It can be anywhere, but you have to tell it where it is. I'll quickly share my screen. So if you go to the file preferences, this is the place where you save it. And you should always save your sketches in this folder. You can tell it where this folder is, but it makes sense to store your files in this folder.
Yeah, let's say this is a good practice, but that's not necessarily fair, D, because you can open a sketch anywhere, even from a stick or so. But this is
I think it's good practice for the beginning to keep it in the sketch.
Yeah, I think, guys, you are both right, but there is only one difference. If you put everything in one folder, and you tell this to the Arduino, as Ferdi said, then you are going to find this in your sketchbook. If you go File, Sketchbook, you find all the sketches there. Otherwise, as Ahmed said, you can just open it from anywhere.
Just going through the, since we're gonna talk about this, let's go through the
Your screen.
menus. Yeah, I will share it, but not anymore. Okay.